In today's lesson, we are going to find the limits using some algebraic properties. So a lot of these are pretty kind of self-explanatory, but we're going to go over them. For the sake of the notes, I'm going to have the limit as x approaches c of f of x, and I'm going to say that that equals L. And then I'm going to have the limit as x approaches the same value c of the function g of x equals m. So two limits approaching the same value, different functions. So the sum and difference rule for limits is if I have a limit as x approaches a value of the function f of x plus g of x, you can basically take the limit of each of them separately and then add it. So it could be the limit L plus the limit M. So an example could be if I have the limit as x approaches 2 of x to the third plus 4x squared minus 3. That is the same. I don't have a lot of room here, but the limit as x approaches 2 of x to the third plus the limit as x approaches 2 of 4x squared plus the limit as x approaches 2 of, that's supposed to say 3, and then this is supposed to say minus here. Okay, so you can just break it apart and look at each one individually. So these are all pretty just basic functions, so you can find the limit by just direct substitution. So on your notes, write nice and small. I'm going to cheat and kind of go into the second box. So this is 2 to the third plus 4 times 2 squared, and then the x value 2 when y is 3, so y is just always 3, so minus 3. So that is 8 plus 16 minus 3 is 21. Okay, and now same idea for the product rule. So if I have the limit as x approaches value c, and I have f of x times g of x, that will be equal to the limit from f of x times the limit from g of x. So an example is, so limit as x approaches 1/2 of the function 3x squared times 2x minus 1. Just like the last one, you can break that apart. So I could have the limit as x approaches 1/2 of 3x squared times the limit as x approaches 1/2 of 2x minus 1. All right, so if I just plug in, I can do direct substitution again. So 3 times 1/2 squared times 2 times 1/2 minus 1. Well, I know this right here is going to, because I should have brackets around these anyways, this is going to be 0, and 0 times anything is 0. All right, 3 more properties. Constant multiple rule is simply if you have a limit as x approaches a value, and let's say we have a constant times a function. All that means is it is the same as the limit as x approaches the value of f of x, and that constant can come out in front. So you can find the limit of the function and then multiply by the constant. So an example, the limit as x approaches 4 of 3x squared is the same as 3 times the limit of x approaches 4 of x squared. So plug in, 4 squared is 16, and 3 times 16 equals 48. Okay, quotient rule, it's just like the other rules. If I have a limit of a quotient, f of x over g of x, I can simply find the limit of f of x, L, and divide it by the limit of g of x, M. So if you have the limit as x approaches 3, x to the 4th plus x squared minus 1 all over x squared plus 5, you can find the limit of the numerator over the limit of the denominator. And basically we can just do direct substitution again. So I have 3 to the 4th plus 3 squared minus 1 over 3 squared plus 5, which should get you 89 over 14. Okay, last property, the limit as x approaches c, so the power rule. If we have a function raised to a power, you can simply just find the limit, that's supposed to say to c, find the limit and raise it to the same power. So if I have the limit as x approaches -4 of a function x plus 3 to the power of 1998, find the limit here by doing just direct substitution, -4 plus 3, and then raise it to the power. So that is -1 to this large power, ends up just going to +1. Okay, so although all of those properties were pretty self-explanatory, but it's nice to know what you can and can't do with limits. Now we're going to quickly look at composite functions. So from pre-calculus, you should remember a composite function looks like this, where it's like f of g of x. So if we're looking at these two graphs, in this case I have h of x and g of x. The first one, let's look at the limit as x approaches 1, h of g of x. So first, just look at the limit as x approaches 1 of the inside function g of x. So as we're approaching 1, it equals 3. So then this changes the limit to the limit as x approaches 3 of the outer function h of x. Okay, so switch over here as we're approaching, +3, not -3, sorry, over here. H of x is approaching 1. Okay, let's do one more. The limit as x approaches -3, g of h of x. So you need to look at the limit as x approaches -3 of the inner function. So h of x approaching -3 is 1. So then this turns into the limit as x approaches 1 of g of x. So now this goes back to 3. So there is your lesson on some properties of limits and composite functions. Good luck with the lesson.